Of the two reactions that I was given, I believe the reaction A is going to proceed faster. I think it's more stable and more favorable because of the resonance present in it. If you look over here through this resonance, the carbocation can form in multiple ways. We don't really have, aside from the resonance, we have an aromatic ring. We don't have any additional with the hydrogen. So for that reason, I believe product A is going to be more stable. So bromine is the leaving group of both of them. Bromine approximately has a dissociation energy of around 275 kilojoules over moles. And the nature of the leaving group, it's a pretty good leaving group because according to the periodic table, it's lower, and as we go down in the periodic table, the strength of our leaving group increases, so bromine is a good leaving group. So now, because A is our more stable product, we know it's going to have a smaller activation energy in order to proceed faster, because a bigger activation energy is the rate determining step, which is a slow step. So for that reason, our activation energy for A is going to be shorter. And that product is also going to be lower in energy. Well, the intermediate is going to be lower in energy, and that's because it's a thermodynamic product, because it's lower in energy compared to unimolecular structure B, which is kinetic. So the reaction precedes SN1. We can tell because of the formation of a carbocation. We weren't given any specific solvents in mind. However, because it's SN1, we know that it could proceed efficiently with any polar protic solvent. And then according to Hammond's postulate, we see that we have an endothermic reaction. The products are higher in energy than the starting material. So because of that, we know our transition state is late, which means that it's going to be closer to your products or intermediates, meaning that our transition state will be most similar to our intermediate because it's in the late stage rather than in the early stage, where it'd be closer to the reactants.